Hello everyone, this is Muhammad Sabil. I am pursuing my BTech second year in Srinivasa Ramanujam Institute of Technology in the Computer Science and Engineering with specialization Artificial Intelligence and Machine Learning branch. Today, my topic is about 0 by 1 knapsack problem using dynamic programming. Before entering into the topic, let's see the content what we are going to discuss today. So, first, we will discuss about dynamic programming, and then next uses of dynamic programming, and then what is knapsack problem, and then types of knapsack problem, and our topic 0 by 1 knapsack problem using dynamic programming, and an example of 0 by 1 knapsack problem using dynamic programming. So let's start our topic by discussing about the dynamic programming. So let's see what is dynamic programming. So dynamic programming is a method used in mathematics and computer science. So dynamic programming is used to solve the complex problems by breaking them down into the subproblems. So the solution of the each subproblem is stored as a result. At last, those solutions of the subproblems are combined together and form the solution of the complex problem. Let's see the uses of the dynamic program. So first is optimal substructure. Optimal substructure means that we combine the optimal results of the subproblems to achieve the optimal result of the bigger problem. As we discussed in the previous slide that the complex problem is divided into subproblems and those subproblems are solved first and the solutions of that subproblems are stored as a result. But finally, those solutions of the subproblems will be combined and then we get the solution of the complex problem. Next is overlapping subproblems. The same subproblems are solved repeatedly in different parts of the problem. Let's start our main topic, that is knapsack problem. Now let's discuss about the knapsack problem. So knapsack problem is the example of the combinational optimization problem. So knapsack problem is also known as rucksack problem. So knapsack problem is also known as rucksack problem. So the name of the problem is defined from the maximization problem as mentioned below. So given a bag with maximum weight capacity of W and a set of items, each having a weight and a value associated with it, decide the number of each items to make it in a condition such that the total weight is less than the capacity and the total value is maximum. So knapsack problem means that a set of container, that a container is given with some limit of weight. Now they also given the set of items with the values and the values and the weight assigned to it. Now we have to arrange those weights less than the capacity, therefore that the cost or the profit is maximized and the weight is less than the capacity. This is known as the knapsack problem. So let's see the types of knapsack problem. So knapsack problem can be classified into the following types. First is fractional knapsack problem, and then 0 by 1 knapsack problem, and then bounded knapsack problem, and then unbounded knapsack problem. Now we will discuss about the 0 by 1 knapsack problem using dynamic programming. So given n items where each item has some weight and profit associated with it and also given a bag with capacity W. That is, the bag can hold at most W weight in it. The task is to put the items into the bag such that the sum of profits associated with them is maximum possible. As we discussed, like 0 by 1 knapsack problem, a container is given with the weight. Now we have to arrange the items such that the profit is maximum and the weight is less than the capacity. In the next slide, we will discuss about the example of 0 by 1 knapsack problem. So let's discuss the example of the 0 by 1 knapsack problem. So here is the problem. So in the problem it is given that weight is equals to 1 comma 2 comma 3 and the profit is 10 comma 15 comma 40 respectively of the weight. So for the weight 1 profit is 10, for weight 2 profit is 15, for weight 3 profit is 40 and the capacity of the bag is 6. Okay, so first we will discuss the formula. So formula is m of I comma w is equals to max of m of I minus 1 comma w comma m of I minus 1 minus w of I plus p of I. So if no element is filled, then the possible profit is 0. If the no element, any element is not filled in the bag, so the bag will be empty. So 0 0 0 0 0. Okay, so next, if we fill the first item in the bag, so the following procedure will look like this. So if we insert or if we fill the first item whose weight is 1, whose weight is 1, so for the weight 1 the profit is 10. You can see here, for the weight 1 the profit is 10. So first we will insert into the bag whose weight is 0. So if we cannot insert the 1 kg bag, so the profit will be 0. We can insert 1 kg in the capacity 1 and then 2 kg capacity, so here also we get the profit. Like this we will insert that item whose weight is 1 kg. So in the all 5 other cases we will get the profit as 10. So now let's see to filling the second item whose weight is 2 kg. By using this formula we will find the profit. Okay, so weight 2, the capacity of the bag weighs 0, so we cannot insert, so the profit will be 0. And then the bag capacity is 1, so, but we have the weight 10, so 2, so we cannot insert, so we just insert the profit 10 from the previous. Now the pack capacity is 2 and the weight of the item is also 2, so we can insert, so the profit is 15. Now you can see here the back capacity is 3 and the profit and the item is 2, so we can insert. Let's substitute this, like I is equals to 2 and w is equals to 3. So I is equals to 2, w is equals to 3. By solving this we got maximum of 10 comma 25. So in these two values maximum is 25, so we take 25 as a maximum value and then we insert it in the third slot, and like this we will insert in the fourth slot, fifth slot and then sixth slot. So like this, by substituting the I value and w value in the formula, and we will get the profit. So next is for filling the third item. So in the third item the capacity is 3 and the maximum capacity in the first is 0, so we cannot insert, so we will return it as 10. And then in the capacity 1 we cannot insert, so the profit is 10. So and then next to 15, so the capacity now become 3, so the weight is also 3, so we can insert. So we know that for 1 the profit is 10, for 2 profit is 15 and for 3 profit is 40, so we can write here 40. By substituting this we can write, by substituting the I value and j and weight value in the formula, we will get profit as 40 and then 55 and then 65 and then 50. So we just note down the profits: 40, 50, 55, 65. So the profit, the maximum profit is 65. By filling all the items, by filling all the items in the bag, we got profit 65. So just we selected the first item, second item, third item, we can get the maximum profit, that is 65. So this is the our maximum profit by putting or by filling the items given. This is my topic about dynamic programming 0 by 1 knapsack problem. And when last we discussed about 0 by 1 knapsack problem using dynamic programming with some example. So thanks for watching my video. Thank you.